This is a video on separation of variables. We're going to solve antiderivatives that have variables of two terms, like this one, 2x over y. So we want to solve the differential equation, dy dx equals 2x over y. I'm going to multiply the y to the other side. At the same time, I'm going to move the dx to the other side. So I am separating each variable. The antiderivative here would be y squared over 2, and on this side it would be x squared plus any other constants. Finally, the last thing I'm going to do here is multiply everything by 2, so that it is y squared and 2x squared. Now you could write 2c, but c is just any old constant anyway, we don't know, so we're just going to keep it as c. Last thing we're going to do here is move everything to one side to write it in the format of something like this: y squared minus 2x squared. And you could write plus c or minus c. Again, we don't know what c is. If c had been negative, it would now be positive. So c is some sort of constant. And then this is some equation here. And if you wanted to have the x positive, you could change it around like this. And so this is an example of an equation of a set of hyperbolas. So to solve this differential equation, find the particular solution for y if we already know y equals 4 when x is 3. So again, we'll do the same sort of process here. Taking the antiderivative, multiplying everything by 2, and again the c is just some constant, and moving things to one side. This time though I'm just going to keep the c on the other side, and that looks like it's a set from a family of circles. X squared plus y squared equals c. We do have a condition here. Remember, we have that y is 4 when x is 3, so plugging those in you would get 9 plus 16 equals c, so c would be 25. So the final solution is x squared plus y squared equals 25. So it is a circle with a radius of 5. Last example here, again, separation. I'm going to divide the y this time. I'll move the dx over 2, so I'll have dy over y. I'll keep the 3 here on this side, and I'm going to move the dx here. This now would be a natural log of y, and here we would 3x plus c. We need to solve for y. We can't keep it in terms of the natural log here. So rewriting using bases of e, we would have the absolute value of y equals e 3x plus c. Now the 3x plus c we can separate by rules of exponents and bases, like that. So that's multiplication of e to the 3x times e to the c. E to the c is some sort of number, and so c is any constant anyways we're not really sure of, so it's going to be absolute value of y equals that constant, so I'm just going to call it c again, times e to the 3x. Because we have the absolute value here, to get y by itself, we could have it written as y equals plus or minus the c e to the 3x. And so we have some sort of exponential function here. Alright, so that's a process of separating the variables. Why don't you try those two problems on your own and work on those and bring them to class tomorrow.